If you have ever taken a multivitamin, gone to the bathroom an hour or so later, and noticed your urine was this glowing, bright, almost neon yellow color, well, you have just watched vitamin B2 at work. Welcome to another custom-tailored deep dive. We are so glad you're joining us today.
Yeah, thanks for being here.
Usually when we talk about nutrients and health, we are dealing entirely with the invisible, right? You swallow a supplement or eat a handful of spinach, and you just have to kind of blindly trust that somewhere deep inside your biology, those molecules are doing their jobs.
Right. You just assume it's working.
Exactly. But today, our mission is to unpack a stack of clinical research, health studies, and nutritional literature centered on a single fascinating molecule that completely breaks that rule. It is vitamin B2, also known as riboflavin, and you can literally see it passing through your system.
You really can.
So our goal today is to shortcut your path to being totally well-informed about a nutrient that basically keeps your biological engine running, but remains, honestly, surprisingly misunderstood.
It really is misunderstood. I mean, most people have a vague awareness of the B vitamins, but B2 often just gets lost in the alphabet soup of modern nutrition.
Right, it's just another letter on the bottle. But watching that bright yellow excess vitamin physically leave your system is such a striking visual. It hooked me immediately when we were looking at the research.
What's fascinating here is that the scientific naming of the molecule actually tells you exactly what to expect when you see it. The flavin part in riboflavin comes directly from the Latin word flavus, which translates literally to yellow.
Oh, wow. I have no idea.
Yeah. So when scientists isolated it, they essentially just named it the yellow vitamin.
That is amazing. Okay, let's unpack this, because it's not just floating around in our bodies to put on a colorful light show in the bathroom. We really need to understand what this bright yellow molecules is actually doing inside your cells every single day.
Absolutely. To understand its role, we have to start with its core classification. Vitamin B2 is a water-soluble vitamin. Now, this is a crucial biological reality for anyone listening.
Meaning what, exactly?
Well, water-soluble means your body simply cannot store it. You can't stock up on it by eating a giant meal on Sunday and expect it to last until Thursday. It has to be consumed constantly.
Right, it's just passing through.
Exactly. And once it is in your system, it takes on two massive responsibilities. First, it is an absolute cornerstone of energy metabolism. It helps your body take the carbohydrates, fats, and proteins you eat and convert them into glucose and ATP.
And ATP is the energy, right?
Yeah, it's the baseline microscopic fuel your cells use to function.
So it's basically the spark plug of the human body. Like
Yeah.
if your body is a car, the food you eat is the gasoline sitting in the tank. But without a spark plug, without that B2 molecule, the fuel doesn't actually ignite and turn into forward motion.
That is a perfect way to visualize
I
it.
just have a heavy tank full of unusable potential.
Right. On a chemical level, B2 helps form two crucial coenzymes. Think of them as biological delivery trucks that carry electrons around inside your cells to generate that energy. Without those trucks, the cellular engine stalls out.
Makes sense.
But that's only half of its job. The second main function of B2 is acting as a powerful antioxidant, actively fighting off free radicals.
Okay, we hear the term free radicals thrown around in skincare ads all the time, but let's ground that. Free radicals are essentially the bad guys, right?
They are. Free radicals are unstable molecules that are missing an electron. Because they're unstable, they bounce around erratically inside your body, trying to steal electrons from your healthy cells, your proteins, and even your DNA.
Yikes. Just causing chaos.
Total chaos. It is a natural byproduct of simply being alive and breathing oxygen, honestly. But this constant cellular damage drives the aging process. It contributes heavily to the development of major health conditions like heart disease and cancer.
So they are basically causing microscopic damage every second. To build on that car analogy from earlier, if B2 is the spark plug turning fuel into motion, its antioxidant property means it is also the anti-rust undercoating.
Oh, I like that.
Yeah, it's neutralizing those free radicals and preventing the biological engine from degrading and rusting out over time.
Exactly. Antioxidants like B2 are generous molecules. They willingly donate one of your own electrons to neutralize the free radical, stopping the damage, without becoming unstable themselves.
That is so cool.
It is. That dual function, the spark plug and rust proofing, is why it is so critical. Without B2, basic cellular growth stalls, the production of red blood cells slows down. Your fundamental bodily maintenance just grinds to a halt without a steady supply of this yellow molecule.
Which brings up an obvious biological dilemma, right? If our bodies are constantly burning through B2 for daily energy, and constantly sacrificing it to fight off cellular rust, we must be absolutely desperate for a steady supply.
We really are.
Especially since, as you emphasize, we can't store it for later. So where are we supposed to get it, and how much can we actually take in at once?
Fortunately, B2 is abundantly available in a wide variety of whole foods. You will find excellent amounts in leafy greens like spinach and beet greens, as well as crimini mushrooms, asparagus, and sea vegetables.
Okay, sounds delicious.
But you also find very robust amounts in animal products: eggs, cow's milk, certain meats, and fortified foods like breakfast cereals.
Okay, so eating a fairly standard, varied diet should theoretically have us completely covered.
You would certainly think so. But the biological bottleneck here is fascinating. Your body has a hard, unyielding ceiling on how much it can process at one time.
Really? Like a limit?
Yes, you can only absorb about 27 milligrams of B2 in a single dose.
Wait, let's put that into perspective for a second. What does 27 milligrams actually look like on a plate?
It's a massive amount of food. A whole egg contains about zero point 0.2 milligrams.
Okay.
A cup of milk is around zero point 0.4 milligrams. So you would have to eat an incredibly massive feast to hit 27 milligrams from whole foods in one sitting.
But that completely changes when you look at the supplement aisle. I mean, you can go to the pharmacy and buy a B-complex pill that packs 50 or 100 milligrams of B2 into a single capsule.
Precisely. And this is why you get that neon yellow visual we talked about. If you swallow a 100 milligram pill, your digestive tract grabs its maximum capacity of 27 milligrams, and the remaining 73 milligrams is treated as absolute waste.
It just gets filtered straight out through your kidneys and into your bladder.
Exactly. It's flushed right out.
You mentioned an Achilles heel in our biological setup earlier, and it wasn't just this 27 milligram absorption limit. There is another vulnerability surrounding B2 that honestly blew my mind when we were reviewing the clinical data.
Yes. The light issue.
It has to do with how fragile the vitamin itself is out in the real world.
Yes, this is easily one of the most practical, actionable takeaways we found. The molecular structure of vitamin B2 is incredibly sensitive to light. It undergoes something called photodegradation.
Are we talking about direct, harsh sunlight or just ambient light?
Just ambient, everyday, visible, and ultraviolet light. The B2 molecule literally absorbs light energy. It's actually why it appears yellow to our eyes. It is absorbing the blue and ultraviolet spectrums and reflecting the yellow.
Right.
But when it absorbs that light energy, its electrons get excited, and the chemical bonds holding the vitamin together physically shatter.
Wow.
Yeah, it degrades into useless byproducts.
That is wild to think about in the context of how we buy our food. Think about your typical grocery store run. You go to the dairy aisle, which is almost always illuminated by rows of incredibly bright, cool-toned fluorescent bulbs.
Exactly. If you are buying milk, cheese, yogurt, or other dairy products that have been sitting out in those brightly lit coolers, inside clear glass bottles or semi-transparent plastic jugs, the strength of the vitamin B2 inside them is actively degrading right there on the shelf.
That's so crazy. The light is literally destroying the nutrient before you even put it in your cart.
It really is.
So all that healthy milk might be nutritionally compromised by the time you pour it into a glass at home.
It is a very real possibility, which is why the data provides a surprisingly simple lifestyle fix. Whenever possible, purchase your dairy products in completely opaque containers.
Like the old school paper ones.
Exactly. Thick cardboard cartons, heavily colored plastics, anything that acts as a physical barrier to the light will preserve the B2 content.
Okay, if we stack all these variables up, a very clear picture starts to emerge. We have an essential vitamin that acts as our biological spark plug and rust protection. We can't store it. We have a strict limit on how much we can absorb at once. And on top of all that, the grocery store lighting might be silently zapping it out of our food.
Yeah, when you put it like that, it's a lot.
It sounds like it's actually pretty easy to slip into a deficit without even realizing it.
It is far easier than most people assume. And this brings us to a massive, under-discussed issue, the hidden deficiencies.
Right, so who is actually falling through the cracks here?
It is a diverse group. Older populations are naturally at risk due to decreased appetite and absorption issues. People who consume large amounts of alcohol regularly often require serious supplementation because alcohol impairs absorption.
Makes sense.
Vegans and dairy-free individuals are at a significantly increased risk because dairy and meats are such dense bioavailable sources. Pregnant and breastfeeding women also have much higher daily demands to support fetal growth, leaving them vulnerable.
What alarmed me wasn't just the specific vulnerable groups, but how widespread this is globally. even among healthy populations.
Hmm.
I mean, instead of just looking at food deserts, the clinical studies show massive shortfalls across the board.
The global data is staggering. Look at a 2015 study out of South Korea. Researchers in Seoul analyzed over 400 seemingly healthy adults.
Right.
They conducted rigorous 24-hour dietary recalls and analyzed urine samples. They found that a full 28% of these healthy adults were consuming less than the daily recommended amount.
Wow.
And when they checked their biological markers, a full one-third of the subjects had inadequate riboflavin status.
And the craziest part of that Korean study is that these subjects weren't eating junk food. They were actively eating traditional diets, rich in B2, whole eggs, pork, kimchi, and they were still coming up short.
We see a different angle of the same problem in a 2015 study from India, which looked at children and teenagers with type 1 diabetes.
Oh, right, because of the diet restriction.
Exactly. Because managing diabetes requires such strict dietary limitations on what and when they can eat, these kids were consistently getting less than 50% of their recommended daily B2.
That is heartbreaking. They are missing half their biological spark plugs just trying to manage their primary condition.
Right.
And then you have that massive baseline data from China and Australia. In 2014, they looked at over 1,200 people, and a staggering 97.2% of the participants had an inadequate intake of B2 at the start of the study.
Yeah, almost everyone. And what's crucial about that specific study is what the B2 deficiency was linked to, persistent anemia.
That part really threw me off. We usually associate anemia, the lack of healthy red blood cells,
Right.
purely with an iron deficiency. Why does B2 matter for iron?
Because the body is a deeply interconnected system. Animal studies reveal that vitamin B2 is required for the body to actually mobilize and utilize iron.
Wait, really? So the iron is just stuck?
Yep. You can have plenty of iron stored in your cells, but without B2, those iron stores remain locked up and unusable. You could eat spinach and red meat all day, but if your B2 is rock bottom, you can't absorb the iron efficiently, which triggers the anemia.
Wow. And if you don't catch these deficiencies early, the physical symptoms escalate from standard fatigue into some genuinely wild, uncomfortable territory.
The physical manifestations are quite striking, yes.
You get things like angular cheilitis, which is this deep, painful cracking and sores at the very corners of your mouth. You see hair loss. In severe long-term cases, you see cataracts forming, which is the physical clouding of the lens in your eyes.
It's awful.
And my personal favorite, well, favorite is the wrong word, but it sounds like something out of a science fiction movie.
Mm.
A highly specific, swollen, magenta-colored tongue.
Yeah, that one is very distinctive. It paints a very clear picture of total systemic breakdown.
So what does this all mean? I want to push back on this for a second. We've established that there are no known tolerable upper intake limits for B2. Taking excess amounts isn't toxic. The worst-case scenario documented is some mild itching or light sensitivity if you take completely absurd doses.
Right, it's very safe.
If there is no real toxic ceiling, and we just pee out the excess anyway, shouldn't we all just be swallowing a supplement every morning to ensure we never get a magenta tongue or locked up iron?
It is a completely logical question. And while the standard nutritional advice is always to optimize your diet with whole foods first, the clinical data strongly supports the sheer power of targeted supplementation.
Especially because of the brain stuff, right?
Exactly. The most profound effects of B2, the data points that truly stand out, aren't just happening in your blood or on your skin, they are happening deep inside your brain.
This was the most surprising part of the deep dive for me. The data on migraines alone is incredible.
Let's look at the mechanism first. Migraine brains often show signs of mitochondrial dysfunction. The mitochondria are the powerhouses of your cells. If they aren't generating enough energy, it can trigger a migraine.
Okay, so a low battery warning, basically.
Essentially, yes. Because B2 is the literal spark plug for cellular energy, flooding the system with it can correct that energy deficit.
Which perfectly explains the results of the 2015 German study we found. They took 130 adults suffering from 3 or more debilitating migraines every single month. They gave half of them a targeted supplement containing B2, magnesium, and CoQ10.
And the results were fantastic.
Within 3 months, the treatment group went from averaging 6.2 migraine days a month down to 4.4 days.
Yes. And while erasing nearly 2 days of agonizing pain a month is huge for adults, the data is even more compelling for children and adolescents.
Oh, definitely.
An Italian study gave high doses of B2 between 200 and 400 milligrams a day to 13-year-olds. Over 68% of those kids saw their migraine frequency literally cut in half.
That is life-changing for a kid.
It really is. Another study from the Netherlands with children aged 6 to 13 showed significant measurable drops in tension-type headaches, too.
And what the Italian researchers explicitly noted was that B2 is entirely devoid of adverse effects. If you are a parent, you are understandably hesitant to put a 13-year-old on heavy, daily pharmacological painkillers. B2 offers a highly effective, completely non-toxic therapeutic option.
It's a great tool to have.
But the neurological benefits don't stop at just blocking pain. It heavily influences behavior and attention, too.
This is where we see B2 interacting directly with our mood and psychological stability. A Norwegian study analyzed adults with attention deficit hyperactivity disorder, or ADHD.
Okay.
They discovered these adults had significantly lower blood levels of vitamin B2 compared to a neurotypical control group. More importantly, the lower their B2 levels dipped, the higher their clinical ADHD symptom scores climbed.
That correlation is wild.
Uh-huh.
And an Australian study tracking teenagers over 17 years found that lower intake of B vitamins was directly associated with aggressive and delinquent behaviors.
Yeah.
They noted that the rapidly developing adolescent brain is incredibly hungry and incredibly susceptible to nutrient insufficiency.
And here's the why behind those behavioral shifts. B vitamins are required cofactors for synthesizing vital neurotransmitters.
Okay, unpack that a little.
For example, your body needs B2 to create the enzymes that convert the amino acid tryptophan into serotonin. Serotonin is the primary chemical messenger that regulates your mood, your happiness, and your emotional stability.
Here's where it gets really interesting for me. If we think about this visually, B2 isn't just passively floating around in your gray matter. It is acting like a neurological traffic cop.
A traffic cop, I like that.
Yeah, it's standing in the busy intersection of your developing brain, actively directing the assembly line that makes serotonin, making sure the emotional and physical traffic is flowing smoothly.
Right.
When that traffic cop has to go on a coffee break because you are deficient in B2, you get immediate pileups, you get migraines, you get aggressive behavior, you get inattention.
I love that analogy. It perfectly captures how a single microscopic molecule can regulate the massive, complex flow of chemical signals that dictate how we feel and how we interact with the world around us.
So if B2 is acting as this vital traffic cop for the brain in our younger years and keeping the daily energy flowing, what happens if we look at the long game?
What do you mean?
Like, if it is acting as an anti-rust coating, protecting our cells from free radical damage, does the steady supply of B2 protect us from long-term, age-related diseases?
The clinical data certainly points in that direction, starting with significant quality of life improvements. Take premenstrual syndrome, or PMS, for example.
Okay.
Researchers utilized data from the massive Nurses' Health Study 2, tracking thousands of women over a decade. They found that women who maintained the highest dietary intake of vitamin B2 in the 2 to 4 years prior to developing symptoms ultimately had a 35% lower risk of incident PMS.
A 35% risk reduction is massive. And what I appreciate about that study is that they grounded it in reality. They noted that achieving that protective level of B2 doesn't require some impossible extreme diet.
Not at all.
You can hit those numbers with just 1 to 2 servings of fortified cereal a day, or about 6 to 7 daily servings of B2-rich whole foods, like milk, spinach, or red meats. It is highly doable.
It is incredibly attainable. But if we connect this to the bigger picture, the conversation around long-term cellular protection inevitably turns toward cancer prevention. And the core mechanism researchers focus on here is a substance called homocysteine.
Okay, stop right there. What exactly is homocysteine?
Homocysteine is an amino acid that naturally forms in your blood as your body breaks down proteins. In normal amounts, it's totally fine. But if your homocysteine levels get too high, it becomes toxic.
Toxic how?
Think of high homocysteine like microscopic sandpaper aggressively scraping the delicate inner lining of your blood vessels and stressing your cells. Over time, that constant scraping and inflammation can trigger cellular mutations, which is strongly linked to an increased risk of cancer.
Ugh, that sounds awful. So where does B2 come in?
Vitamin B2 acts as a chemical cleaner. It actively helps your body break down and recycle that homocysteine into something harmless, basically taking the sandpaper away.
That makes perfect biological sense.
Yeah.
So higher B2 equals lower homocysteine, which should equal lower cancer risk. But when we actually look at the clinical studies on this, the data is a bit of a roller coaster.
Roller coaster is a very polite way to put it. The results are notoriously inconsistent. Let's look at breast cancer first.
Okay.
A massive Chinese meta-analysis covering over 12,000 patients, alongside an Australian study following 20,000 women, both arrived at very cautious conclusions. They found weak but suggestive evidence that higher dietary B2 inversely correlates with breast cancer risk.
So essentially, it might offer a slight protective decrease, but the evidence simply isn't a slam dunk.
Exactly.
Okay, weak but suggestive. We can handle that. But then we get to the data on colorectal cancer, and the research basically fractures into two entirely contradictory realities.
Yeah, this is where it gets confusing for a lot of people.
In 2013, a joint U.S. and German study analyzed over 88,000 women. They found that a high total intake of B2, combining both diet and supplements, significantly reduced the risk of colorectal cancer. They had a massive sample size and were incredibly confident in the protective link.
But then you fast forward just 3 years to 2016, researchers analyzed an even larger cohort, over 144,000 people in the U.S.,
Right.
and they found absolutely no significant association between vitamin B2 intake and colorectal cancer risk. The protective effect completely vanished.
Wait, how is that possible? How do two incredibly rigorous multi-decade studies involving tens of thousands of people look at the exact same yellow molecule and the exact same type of cancer and arrive at completely opposite conclusions?
Because context in nutritional science is everything. The authors of the 2016 study recognized this and pointed out a crucial defining nuance. Their specific cohort was made up of nurses and health professionals who already had relatively high baseline intakes of vitamin B2.
The starting line was different.
Precisely. When your entire study group is already well-nourished, already eating a balanced diet, and already hitting their daily B2 targets, adding a little extra B2 on top isn't going to trigger a dramatic sudden reduction in cancer risk.
So they were already protected.
Right, their high baseline intake effectively masked the benefit of the vitamin. It exposes the inherent limitation of observational research. If you only study people who are already getting enough of the nutrient, you will never see the profound benefit that comes from correcting a deficiency.
That makes so much sense. It is like trying to measure the life-saving impact of handing a glass of water to someone. If you hand a glass of water to someone who just drank a gallon, it has zero measurable impact. But if you hand that exact same glass of water to someone who has been wandering in a desert for 2 days, it is instantly life-saving. The water is the same. The baseline context of the person receiving it changes the result entirely.
That is a brilliant way to frame it. The baseline status dictates the observed outcome.
Okay, we have covered a massive amount of biological and clinical ground today. Let's do a rapid-fire recap so you can take this knowledge with you. Vitamin B2, riboflavin, is your unstorable daily cellular engine fuel. It is the vital spark plug for your energy and the anti-rust coating neutralizing free radicals.
And remember, it comes with a hard biological ceiling. Your body will only absorb about 27 milligrams at any one time, discarding the rest.
Because it synthesizes essential neurotransmitters, keeping those levels stable has profound documented effects on reducing migraines, regulating ADHD behaviors, and stabilizing mood.
It is also directly linked to preventing anemia by unlocking your body's iron stores. It clears out that microscopic homocysteine sandpaper, and it can significantly slash the risk of PMS.
And above all, if you take nothing else away from this, keep your dairy in the dark. Buy the opaque milk cartons to protect that fragile molecule from shattering under the grocery store lights.
Which actually leads me to a final thought based entirely on the vulnerabilities we've uncovered today. This raises an important question for all of us to consider.
What's that?
If vitamin B2 is so easily and permanently destroyed by ambient light, and our modern supermarket designs heavily favor brightly lit aisles, open coolers, and perfectly transparent plastic packaging just to make the food look appealing to the consumer's eye.
Yeah.
Is our modern visual aesthetic actually stripping our food of essential life-saving nutrients before it ever even hits our shopping carts?
Wow. That is definitely something to chew on the next time you're standing in the dairy aisle staring into those fluorescent coolers. Are you buying actual nutrition, or are you just paying for a well-lit display? Thank you so much for joining us on this deep dive. We hope it gave you a few new biological spark plugs. Keep questioning the world around you, keep looking for the why, and we will catch you next time.